All right, let's do some Mathity-Math. Today we're doing some descriptive statistics, and it says better understanding the mean and the standard deviation. This is example 2. Okay, let's do this thing. The question says, Dr. Dragon is quizzing all of her students. The quiz had 7 questions. The mean grade was 4, and there was a standard deviation of 2. To shift to a percentage scale, Dr. Dragon multiplies each grade by 14 and then adds 2. And so the question says, well, what is the new mean and what is the new standard deviation? All right, now I could just go ahead and answer this straight away for you guys, but I don't think there's a real benefit to that. So maybe we did this last video, I'll do it again. Let's build an experiment to kind of see what happens when we do this, and we can kind of learn the rules of the game. So again, I'm going to make a simple data set here. This is just a make-believe data set. Let's make this one a little different. Let's call this one 2, 2, and 4. Okay, that is our data set. Okay, so there's 3 points of data, 2, 2, 4. And let's see what happens here. So when we do this data set, we're going to find the mean, and then we're going to find the standard deviation. Okay, and remember, this has nothing to do with the question. This is just like an experiment to help us really understand what's happening here. And so we'll make this first box, straight from the data. And then we're going to make some situations here and really see what happens. Okay. So in this first situation, let's say we multiply by 3. So we're going to multiply everything by 3. In the next situation, we'll add 4. And then for the final situation, how about we multiply by 3 and add 4? Let me look like that, okay? All right, there we go. So we got 3 situations, and we'll see what happens here. So we're going to use our handy-dandy calculator, and we're going to kind of build this experiment to see how it all happens. We're going to need 1, 2, 3, 4 lists. Before I start this, I want to clear out my old lists because I'm sure I got something in there. So I just clear out list 1. I clear out list 2. Oops, I forgot my comma. I clear out list 3. And I clear out list 4. Done. Everything's clear. Okay. So we hit stat and we hit edit so we can fill in our tables. Okay, so table 1 is just going to be our original data, 2, 2, and 4. Okay, list 2 is going to be 2, 2, and 4, but we're going to multiply each one by 3. Okay, so 2 times 3 is 6, 2 times 3 is 6, and 4 times 3 is 12. So we get 6, 6, 12. All right, list 3 is we're going to take our original data, but we're just going to add 4. Okay, so this would be 6, 6, 8. 2 plus 4, 2 plus 4, 4 plus 4. 6, 6, and 8. And then for our last one, we're going to kind of combine the whole thing and see what happens. So we do 2 times 3 and then add 4. 2 times 3, then add 4. And then 4 times 3 and add 4. Okay, so 2 times 3 is 6, and 6 plus 4 is 10. So this is 10. The next one is 10 because they're the same. And then this is 4 times 3 is 12, and 12 plus 4 is 16. Voila, we're ready to rock. So what we're going to do here is we're just going to do L1, L2, L3, and L4. I guess I can put this here so we don't make any mistakes. And see what the calculator tells us. See if we can establish a pattern. Okay, so stats, calculate one variable statistics. We're going to go to L1. And we find, we'll just call it 2.67. Our mean is 2.67, and our standard deviation is 0. It's right here. Excuse me. Our standard deviation is 0.943. So 0.943. Oops, daisy. And I don't know if I pointed that out, but yeah, the X with the line on top. That is our mean. Okay. The calculator got in the way of my handwriting. Sorry. Okay. Okay, now we're going to do the same thing for L2. Okay, we've already put the numbers in. We just do L2. So I hit stat, calculate, one variable statistics, but I'm going to do L2. I don't know if you saw that. To do L2, I hit second, 2, L2. All right. So here we go. Our mean is 8. And our standard deviation is 2.83. Now, before we go any further, let's talk about how this could happen. Well, if you think about this, this is 2 2/3, right? Well, 2 2/3 is the same as what? 6 8/3. And if we multiply that by 3, you get 24/3, which is 8. So you can see here what we learned was when you multiply each value, the mean multiplies by that too. So essentially you took 2.67 and you multiplied it by 3. So by multiplying these numbers by 3, the mean multiplies as well. And so let's see if the same thing happens with standard deviation. I'll just type in, let's see here. And it might be a little off because clearly there's rounding happening, but let's see here. 0.943 times 3. Oh, maybe I should put the right numbers in. 0.943 times 3. 2.829. We got 2.83 here, which does match up. Okay, so we can see here that if you multiply your data by 3, or whatever you multiply your data by, the mean and the standard deviation gets multiplied as well. Okay, so we learned something here interesting. All right, now let's go down to the adding where we just added. Okay, so we're going to do L3. So stat, calculate one variable statistics, and so you can see here, second L3. Okay, so your mean is 6.66. We'll call it 6.67. And our standard deviation is 0.93. 0.943. Okay, now what did we just notice? All right, so when I add 4 to each of these numbers, I just ended up adding 4 to the mean. So when you multiply the numbers, the mean multiplies. When you add numbers, the mean just goes up by that much. And if you subtract it, it would do the same. But what happens to the standard deviation? What changes? Nothing changes. Okay, so standard deviation is affected by multiplying, but it's not affected by adding and subtracting. Okay, so maybe we can make a prediction right here. If we said I want to multiply by 3 and add 4. Well, when I multiplied by 3, this mean tripled, to 8. And then when I added 4, it just goes up by 4. So maybe it'll be 12, right? Not a bad guess. And if I'm guessing over here, I'm thinking the standard deviation is going to multiply by 3 to get this number, and then when I add, it doesn't change. So I think my standard deviation is going to be 2.83. So my guesses, my official guesses, and if I'm wrong, I have to remake this whole video. So here we go. My official guess is the mean will end up being 8 plus 4, which is 12. This is my prediction. And I think the standard deviation will just be affected by multiplying, so it's going to be 2.83. Here we go. I go to stat, calculate, one variable statistics. I'm doing L4. Let me draw that line so there's no confusion. L4. Whew, I'm nervous. Boom, the mean is 12. Ta-da! And the standard deviation has not changed. All right, so we did good stuff here. So we learned some rules here. So going back to our original question, the mean and the standard deviation. Let me just block all this off so we get to work. Okay, so when we started, the mean was 4 and the standard deviation was 2. But then it says I'm going to multiply everything by 14 and then add 2. So when we do the mean, we know that if you multiply the mean by 14, the mean just gets multiplied by 14. Okay, so my mean was 4. So I say 4 times 14 plus 2. Okay, so now my new mean is 58. So I just followed what we learned over here, right? We said when you take a mean number and multiply it, the mean multiplies, and if you add to it, then it just adds as well. So my new mean would be 58. And the standard deviation was 2. Well, let's think what affects standard deviation. Multiplying definitely affects standard deviation, right? Adding doesn't change it one bit. So the only thing that's going to affect our standard deviation is this multiplying 14. Well, 2 times 14 is 28, so our standard deviation is 28. And there you go. Good job. All right, if you want to be notified when I make more problems, please subscribe below. And if there's something you want me to work on or anything like that, just leave a comment, and I'll do my best to help you out. Thank you. Goodbye.